All right, guys, questions on the homework, because they'll probably interrupt us here in a minute with announcements, but questions on any of the homework assignments so far? So far, we've only had two, because we had 661, 662. All right, guys. If we feel good about the homework so far, what we're looking at today are these here. Now you can see there's a significant, or not significant, but there is a difference from what we did Friday, or well, it'd be Thursday. We have two logs. Whenever we solve these here, these logarithmic equations, we need a single log on one side and everything else on the other. So numbers is specifically what we'll have. And the reason I say that is because if this was, say, 2x, we would have to actually use some types or almost estimations to be able to find it, because we wouldn't get x by itself or outside of the logarithm. So our main goal with these here is we need to rewrite it so that both of these logs are a single log. Even if we had them on other sides, we need to get them onto the same side of the equation and get it as a single log. Now we actually have a way to do this, because we said log base b, I'm going to write log base b of m times n is equal to log base b of m plus log base b of n. And we worked with this, especially before spring break, that I could rewrite a single log with what's inside being multiplied as two logs being added together. Means we can also go the other direction. If I have two logs being added together with the same base, we can rewrite it as a single log with what's inside being multiplied. Same thing's true with subtraction, because it just says log base b of m divided by n is equal to log base b of m minus log base b of n. Because if I have two logs with the same base being subtracted, we can rewrite it as a single log with what's inside being divided. So for us here, what that's telling us is that our log of 2x plus log of x minus 5 can be rewritten as log of 2x times x minus 5 is equal to 2. So if we have two logs being added together, we can rewrite it as a single log with what was inside of each log being multiplied together. Any questions on this so far? We good with this here so far? Well, now it looks exactly like we had Thursday, yes? So, to simplify these logs out, we're going to put both sides to the base of 10. And the reason we use 10 is because even though it's not written, the base of this log is understood to be 10. If the base is not written for log, it's 10. And the base of our natural log is e. Now for us here, 10, guys, 10 to the log base 10 is going to simplify out, leaving us with 2x times our x minus 5 is equal to 10 to the second power. Now, 10 to the second power is 100. We could have written that out already. We didn't necessarily have to rewrite it out as 10 squared. We could have just squared it and gone from there. The other side, we do have to distribute the 2x. 2x times x is 2x squared. 2x times negative 5 is negative 10x. Questions on how we got to this point here. We have a quadratic term, which means we need to get this equation equal to 0. So I'm going to subtract 100 from both sides because we already have the x squared and x term on one side. It's only going to take one step to get the 100 over there with it. If we do that, we get 2x squared minus 10x minus 100 is equal to 0. Questions on this here? We got it equal to 0. Now we just need to solve this quadratic. Yes? We could factor it. We could graph it. We could do the quadratic formula. We can complete the square. We have different ways to do this. So looking at this here, we do have a number in front of x squared, so there's a good chance there might be fractional answers. Is there a greatest common factor between 2, 10, and 100? 2, yes? So to make this easier to work, we could remove that 2 from the whole equation. Do we still have that number in front of x squared? No. So if we're going to have solutions, most likely they're going to be integers. So we could graph it. So we can grab the graphing calculator, say y equals, if it'll let me. Way to bring it back. Y equals x squared minus 5x minus 50. We do see across the x-axis at 2 places. Second graph. One of them is negative 5. The other is 10. So negative 5 and 10 are our 2 solutions. Questions on this here? Now, before we call this problem completely done, I'm just going to go on and check these 2 here. There's our original problem. I'm just going to rewrite it back out. Was log of 2x plus log of x minus 5 is equal to 2. So if we check this with 10, we'd have log of 2 times 10 plus log of 10 minus 5 is equal to 2. I'm going to simplify this a little bit because our first one, log of 2 times 10 would be log of 20 plus log of 10 minus 5, well, that'd be log of 5 is equal to 2. And the 2 places where we have logs, the number inside of them, and both of these here are both positive. And since it is a common log, I could come over here and say log of 10 plus log of 5. Make sure I typed that in right. Probably didn't. Log of 20, not 10. Yeah, that didn't seem quite right. 20 plus log of 5 is indeed 2, which is what we have. Now the other one was log of 2 times negative 5 plus log of negative 5 minus 5 is equal to 2. And if we do some of the simplifying here, two times our negative 5 would be negative 10. Negative 5 minus 5 is negative 10. Well, in both of these here, the number inside the log is negative. If I come over here to the either calculator and say log of negative 10, I'm not going to type the whole thing in. It's going to say domain error. We cannot have a negative number inside the log. So this one doesn't work, which tells us negative 5 is an extraneous solution. The only one that actually works is 10 for this here. That doesn't mean all negative numbers won't work for logs. because the last homework assignment had two values of x that were negative. But if we plug them back in, and the number that finishes up inside the log, here and here is negative, then it doesn't work. We throw it out. Questions on this here? And the main time we'll get this is if we have two logs being added together, we get that product that kind of messes with it, because here negative 10 times negative 10 is positive 100 that offsets. That's why we got that. But it doesn't work in the original problem. Questions on this here? If we look at the next one, log base 6 of 6x plus log base 6 of x minus 1 is equal to 2. Well, the first thing we need to do is rewrite these as a single log. Because if we have two logs with the same base being added together, we can rewrite them as a single log with what's inside being multiplied together. So our log base 6 of 6x plus log base 6 of x minus 1 is the same as log base 6 of 6x times x minus 1. What will we do next? We have to put both sides to the base of 6. Because our 6 to the log base 6 simplifies out, leaving us 6x times x minus 1 is equal to 6 squared. Well, 6 squared is nice. It is 36. Our other side, we will distribute the 6x. 6x times x is 6x squared. 6x times negative 1 is negative, 6x. What do we need to do next? We need to get this equal to 0. So we can subtract 36. Telling us that we have 6x squared minus 6x minus 36 is equal to 0. Again, like the last one, we can come over here and graph it. Now, you might have also factored out that greatest common factor of 6, and since it's just a constant term, it's just a number, we can divide it out. Nothing's going to change for our solutions anyways. The rest of the function will look a little bit different, as we can see here. Blue one's a little bit bigger, but they still cross at the same points. And our two solutions are negative 2 and 3. Now we could have also found that by factoring or quadratic formula, we would have gotten these two solutions here. If we were to take a guess, if one of these wouldn't work, which one would we say would not work? Probably negative 2. Because if we look back at the original function, log base 6 of 6x plus log base 6 of x minus 1 is equal to 2 is what we had, yes? And what we're saying when we're checking it is making sure that what's inside of either logarithm does not become negative, yes? So really what I'm looking at is 6x and x minus 1, making sure neither one of these becomes a negative number, yes? Well, with 3, for this one here, we're saying 6 times 3, which is 18. Our other one is 3 minus 1, which is 2. Okay. Neither one of those became a negative. And we could take the time to type them into the calculator to see if log base 6 of 18 plus log base 6 of 2 does give us 2, and it is true. Because our other one we're looking at is 6 times negative 2, which is negative 12, and negative 2 minus 1, which is negative 3. Making sure neither one of these become negative. Well, incidentally, they both become negative, yes? Which means for us here, these don't work which means our -2 doesn't work, leaving us with x is equal to 3. If a negative is going to work, it has to have some way to offset it. Either we're subtracting x, there's a negative sign in front of x, or it's being squared. There has to have something to undo that, to offset that effect. Questions on this here? How do we feel about these here? Not too bad. It's just one main step, and then we're back to where we were. Do we need to see another example of one of these here? I think we feel good with these. And the only other type that we have, well, it's the same thing, is this here. So we're skipping 2. Well, the difference from this one and the one before is that we are not adding, we are subtracting. Well, when I have 2 logs with the same base being subtracted, I could rewrite it as a single log with what's inside being divided. That's it. That's the only main step to this here, is that instead of having it being multiplied, they're being divided. Questions on how we got to this point here? Our next step is going to be the same as the last one. We're going to put both sides to its base. And here we have both sides to the base of 10. 10 to our log would simplify, leaving us with 3x minus 2 over 2 is equal to 10 to the third. Ten to the third is still a nice number. It's just 1,000. Now we just need to solve this here. Now we don't have any powers, we don't have anything we need to multiply by, so we can just get x by itself. What's the main thing that we have with it? Because we do have multiplication of 3, we have the subtraction of 2, and the whole thing's being divided by 2, yes? So to undo this fraction, what can we do? We can multiply each side by 2. Because here the 2 and 2 will cancel, telling us 3x minus 2 is equal to 2,000. Next thing we would do is add 2 to both sides, telling us 3x is equal to 2002. Me, I graduated high school in 2010. Yeah, so my 10-year anniversary for high school finished up a few years ago. And 10 years for college would be this winter. Some. No. Ten years is a decent amount of time, but it's also not a lot of time all at the same time. Yeah. Questions on this here? We'll look at one more, and then we'll be done for the day. I think that's actually the last one. If I remember right, I might be wrong. 2 more, but I think 1 more and we'll feel comfortable with these, yes? Since we have 2 logs being subtracted, we can rewrite it as a single log with what's inside being divided. What would we do next? Put both sides to the base of 4. Our 4 to the log base 4 simplifies that, leaving us with x over x minus 1 is equal to 4 to the almost to the half. If we do type that in, 4 to the half is indeed 2. 1/2 power and the square root are the same thing. Chapter 5 will go into that and explain why that is, or explain why that is to the best we can. But 1/2 power gives us 2. Now it might be nice to get rid of this fraction, so we're going to multiply both sides by x minus 1. Now on the left-hand side, the x minus 1 and x minus 1 will indeed cancel. But unlike dividing something out, the x plus 1 is still there. It's just not in the bottom of the left side anymore. It's in the numerator on the right. We just moved it from one side to the other. And over here we can distribute 2 times x is 2x. And 2 times 1 is negative 2. I'm going to subtract 2x. Telling us negative x is equal to negative 2. Minus x is 2. Questions on this here? That's it. 33 through 37. 5 problems. Incidentally, all 5 problems are addition. None of them are subtraction. And again, I did the addition. And we looked at those there purely, well, not the addition, but I looked at the subtraction so we could have seen it. We know that it's not too different. We just use a different property